Hello everyone, Siddharth this side, and in this video we will be solving another question on Geek for Geeks, which is top view of binary tree. So in this question, we have to print the top view of binary tree. And what is that? So if we will stand on the top of this tree, like if this tree is beneath us and we will be seeing it from the top, then the nodes that will be visible to us, we have to print, we have to store those nodes into an array list and we have to return that. So let's see how we can solve this problem. So here we have given this tree 1 2 3. Okay, so let's draw it. So 1 2 3 4 5 and 6 and 7. Now what we have to do, we can imagine it as a boundary. We have to print the boundary of this tree, and we can imagine this as a number line. This will give you an intuition how we can solve this problem. So this root node we can mark as 0, and if we will move on the right side, uh, we will be going to the positive side, and if we will move to the left side, then we will be moving to the negative side. So this approach can give you an intuition for solving this problem. So uh, one thing that we can see from this is that we have to print the we have to print the boundary nodes. So we can use here a level order traversal, like this one, then 2 3, then 4 7. But these two node we don't want to print, and if this tree will go further, we have to remove these amount of elements. So how we can solve this? And I already have told you something about this number line approach. We can use this approach. So what we can do, we will traverse this tree using level order traversal, and if we will move to the left side, then we will keep track of the distance on both side, left and right. So if we will move on the right side, then we will be decrementing the distance from its from the node root by -1. Or we can say that we will be uh, if we will be moving on the left side, then we will be decrementing the horizontal distance by -1. And if we will be moving to the right side, then we will be adding 1 to the horizontal distance. Now how this can solve the problem? So uh, what additionally we will be doing here, uh, we will be using level order traversal. So we will be adding this current node into a queue. Apart from this, we will be adding in the start the distance of this root from the node root, which is 0 itself. Now we will pull out this element, and we will add its children to it. So first we will add 2, then 3, and after doing this, we have to add this to the we have to add the distance of these two children from its root node. So 2 is on the left side, so we will be adding -1. Is it 0? So after subtracting -1 from it, it will become 0, -1. So we will be pushing -1 to the queue. Then we will be pushing here +1. So we will be adding +1. Now we will pull this out, and we will be adding children's to it. So first we will add 4, then we will add 5. Now after doing this, we have to push the distance of these two nodes from the 2 itself. So it will be here, it is -1. For 4 it is, so this we will 0 we will pull out, and -1 is also for we will pull out for 2. Now this queue will be having a +1, and it is now we will push the distance of 4 from 2, which will become -2. And for 5 we will be moving right side, so we will add that, so it will become 0 again. Now if you will observe that this distance we have already traversed. So this is the idea that we can use. If we encounter the same distance, then we will not if we encounter the same distance, then these two nodes will follow this. Like if we calculate the distance of mm, these two nodes from the root node, that distance is not unique. So this approach we can use, we can store it in the hash map. in the hash map, which will keep track of the unique elements, and in this way we can filter out these two nodes. But there's problem with the hash map is that it will not give us the short element, as we have to print or store the elements level by level from start to end. But this hash map will not be shorted. Other So one thing we can do, we can short after storing everything into a hash map and then store it into a array list. And another approach we can use tree node, a tree map, because this will return us the short or this will return the sorted elements. So this is the approach that we can use here. So we have to maintain two queues and a tree map. So our first queue will do the same job as level order traversal, and second queue will take care of the horizontal distance, and the tree map will take care of the unique elements, which will filter out these two. And if we will increase the tree from 4 and 5, this will 5, sorry, this is 8, this is 9, then 5 has 6, then it has 7. Then in this case, these distance we will already we can filter out these distances and we will remove these from our array list. So this is the approach that we can use here. So let's move on how we can code this out. So first let's check the base condition. So if root is equals to null, in this case we just have to return a new array list. So return new array list. After this, what we have to do, we have to make two queues. So queue of first one should be node, as we will be storing node here. So this will queue and it should be new linked list. Okay. Now after this, what we have to do, we have to make another queue, and this should be integer as we want to store the horizontal distance. So QUEUE integer, make it capital. This should be horizontal distance is equals to new linked list. And after doing this, what we have to do, we have to make a tree map also, which will be integer and integer. So one, it will store the node. It will store first it will store the horizontal key as a key, horizontal distance as a key, and its pair will going to be the node data. So first it is integer, second one is also integer. Now it should be tm is equals to new tree map. Okay. Now what we have to do, we have to what we had done in the level order traversal, we will be adding our first node root into our queue. So queue dot add, which is queue dot add root, and then we will be adding its horizontal distance as well. So hd dot add 0. Now after doing this, we have to do the same thing that we had done in the level order traversal. So while q dot is empty, so until and unless this will become false, we have to run this while loop. So first we will be polling out this node. So node current is equals to q dot poll. This will give us the top node of the queue. Now after this, we have to pull out the horizontal distance as well. So int horizontal distance, let's make it distance. So we have to pull out it from the hd. So hd dot poll. Now the condition we have to apply in condition for whether we have to put the current node into a tree map or not. And that condition will be if a tree map contains, let's apply not in the start, so contains this distance. So if our tree map does not contain this distance, then we have to add that distance with the node. We have to add we have to add the distance as a key and node as a pair. So tm dot add, what we have to add, we have to first add the distance and then we have to add its node value, so that will be current dot data. So this will do the job for us. Now let's call for the left child and see if it is not null, then we will be adding that as well in the queue. So if current dot left does not equals to null, then what we have to do, we have to add that into the queue as well. So queue dot add current dot left, and now we have to add the horizontal distance as well. So hd dot add, and horizontal distance will be distance -1 for the left side. Now let's do it for the right side as well. So if current dot right does not equals to null, then we have to add this node in the queue as well. So current dot right, and now let's add the horizontal distance as well. So hd dot add, and horizontal distance will going to be distance +1 as it is for the right side. Now after doing this, we will be having all the required nodes in the hash map, in the tree map. Now we just have to traverse into this tree map, and we have to store that into the array list. So let's do that. So after this while loop, let's make a for each loop as well. So for int key in the tm dot key set, and we will be passing key here. Now what we have to do here, we just have to add al dot so we haven't created an array list, so let's create it first. So array list teaser is equals al is equals to new array list. So let's add this into our array list. So al dot add tm dot get this key value. So this will give us the element and it will get stored into our array list. Now in the end, we just have to return this array list. So what we have done till here, we have defined an array list. Then we have defined two queues. First one will be storing the nodes. Second one will be storing the horizontal distance from the root node. Then we have defined a tree map which will store the node's value and the data and the horizontal distance from the node root. And then we have done the same thing that we had done in the level order traversal. First we will be pulling out the node and the distance as well, and then we will be checking if this distance we have already encountered. If we haven't encountered it before, then we will be adding this into a hash map, into a tree map with the distance as a key. This should be t with the distance as key and current data as a current dot data, which is the data of the current node. Then we will be checking for the left side, so it is not null, then we will be adding this as well into a queue and decreasing the horizontal distance by -1, and we will be doing +1 for the right side. So, and in the last we will be traversing into our tree map, and we will be storing each value into our array list. So let's see, let's try to run this. Okay, let's add this as well. Okay, so there is some issue. So this is tm.contains. Okay, this should be tm.contains key, and then cannot find tm.add. Oh, this should be put, not add. And now let's try to run this. So And there is another error, so cannot find symbol, contains key. This should be distinct, and then cannot find symbol, tm dot key set. This should not, we will not be passing here anything. So let's see now. Okay, so let's try to submit this as well. So all the test case have been processed. So thank you. See you in the next video. Bye.